All right, good morning. Hope all is well. Today you get me via the joy of video because I have a meeting this morning. So I wanted to get into day two of 2.5 notes with proportions. Today we are going to talk about similar shapes or similar figures. So on this first slide here, you see the picture of the Hot Wheels car. That is a scale model of the actual full-size car. And what you can see here is, in reality, this Hot Wheels car is a little bit shorter than 3 inches in length and a little bit less than 1 inch in height. And when you look at the actual car, you see that the length is about 184 inches or 15.3 feet, and the height is a little less than 4 foot, but that's an approximation. And so what happens is this car right here, this Hot Wheels car, Matchbox, whatever brand you happen to be looking at, that is a 1/64th scale. What that means is all the measurements of the real car, they shrink them down or divide them by 64 to get to this 1/64th scale car. So if it was a 10th scale model, it'd be 1/10 of the real size. If it was a 5th scale model, it'd be 1/5 of the real size. And so you see these models used quite frequently, especially in building and trades with blueprints and so forth, where you have a smaller model of the original. So we're going to use this information today in regards to similar shapes. So you can see today on our slide here, proportions and similar figures. This is one of our definitions from yesterday's homework. In similar figures, corresponding angles are equal and the ratio of side lengths are equal. So in other words, if you look at these two triangles here, you can see that this triangle is clearly bigger, but their angles, angle B and angle E, are the same. Angle A and D, those angles are the same. And C and F are the same. So they're similar size, similar proportion triangles. The difference here is the ratio of sides. So you can see this one's 10. This is 1.5 times bigger. So 1.5 times 10 is 15. This side's 12. 1.5 times bigger is 18. This one's 8. 1.5 times bigger is 12. And so that's what you see in similar figures. They have a proportion between the sides. In this case, the bigger triangle is 1.5 times bigger. And then the corresponding sides, you can see they match up, they're color coded, and then the angles that match up as well. So we're going to be using this phenomenon today in our notes and in our homework. So this first one here, it says use proportions to find the missing side lengths. So you can see these two shapes here, our pentagons, are similar, and we are going to match up the blue side with the red side. So the big one here, 10 over 8, is going to equal 16 over r. And so now we have a proportion that will allow us to find the missing side length for the smaller pentagon. And again, we know how to solve proportions. Same thing we did yesterday, cross multiply. So 10r is going to equal 128. And we find out that this side right here is going to be 12.8. Now, they didn't give us a dimension in this case, so you could write UN for units, or we could just leave it as 12.8. But they do give you a dimension. You do want to label that accordingly. All right, down below here, you see this scale map of a home, and it says that for this scale, 1/2 of a centimeter equals 2 feet. What are the dimensions of the bathroom? So if we just look at this, we can see this full side right here is 7, and we can see all the way across here it actually ends up being 8 centimeters, and so that allows us to find some of these missing values here. And what happens is we find out that this is actually 2 centimeters here, and this one here is 1.5, but we'll get to that in a minute. So what we have to do then is figure out how many feet each of these is. So we know that the scale is half a centimeter to 2 feet. We know that this length right here is 2 centimeters. So we want to figure out how many feet that is in real life. So we'll cross multiply 0.5x equal to 4. This is really 8 feet. And then we'll do the same thing for this one. That is 1.5 across, because we know that from here to here has to be 5 centimeters. So we got 2.5, and we got 1 right here, so that's 3.5. This has to be 1.5 to make this 5. So 0.5 over 2, 1.5 over x, and we find out that the other missing side is 6 foot. And so the actual size of this bathroom is 8 feet by 6 feet. So we have the centimeter scale. We can use the conversion or the proportion, and that in turn gives us the dimensions of the bathroom, 8 feet by 6 feet. Our final problem today, in dealing with similar figures, is a shadow problem. So we want to know, how tall is this tree? Well, it's not physically possible in all cases to take a tape measure and go ahead and measure the height of a tree. So what we can do, because it's on the ground, is we can actually measure the shadow of said tree. So at whatever time this happens, it doesn't matter whether it's 10 a.m. or noon or 2 p.m., whatever time of day it was, this tree made a 32-meter shadow. We do not know the height of the tree, so we call that x. At the exact same time of day, a 1 meter stick made a 4-meter shadow. So now I have the ratio here, length of the stick over length of the shadow compared to the tree, length of the tree to length of the shadow. And now I can use this proportion to find the height of the tree. So we cross multiply, 4x equals 32. We find out that the tree is 8 meters tall, which is roughly around 29, 30 feet in that area. We don't have to convert it to feet, but just to give you an idea. So this tree here ends up being 8 meters. Again, how do we do that? This right triangle is similar to this right triangle. If you measure them at the same time of day, regardless of the time, you have that length of the shadow. So that's our notes for today. That should set you up well to do day 2. So you have that homework assignment will be handed out to you, and you can get after it.